RISC-V is a global standard. It's not software, it's not open source software.
I'm going to talk about something like many people are actually also very interested about, which is money. How does RISC-V going to lead or the trend for technology?
Yeah, well actually there's more startups in RISC-V than any other architecture in history.
Currently, at least in data centers, like x86 architecture is still dominant.
And by the numbers too.
Yes,
it's not just an opinion. Understanding how to truly collaborate with others is the most important skill you can bring. Hook your career onto a star, make it a shooting star.
Okay, so yes, so please, very happy to have you on our show. If you can, say hello to our audience.
Hello, I'm super excited to be here. Thanks so much for taking time with us to learn a little bit more about where RISC-V is today.
Perfect, I'm very excited because, as you may know, like I've been actively involved in RISC-V like 2 years ago, not as long as you do for sure, but I know RISC-V is currently the major trend technology in the world. And like I said, I've been to RISC-V Summit in Europe. I post videos there, but it's very happy to have our local, Chinese summit. So what do you think about this summit? How do you feel like being in China?
It's absolutely great to be back. I regrettably have not been back for 3.5 years,
Sure.
and I've been to China more than a dozen times, working with different companies and institutes, and I love being here. So I'm super excited to be back, but that's personally.
Yes.
Now, as for the summit has been super exciting. We had to actually cut off registration. We hit 2,000
Yes.
like a week ago, and so we had to stop. So I think we were sold out, and the excitement and the engagement and really getting to see all the progress has been perhaps the most amazing thing. In these last few years, a lot of ideas have gone through to production and actual implementation. I'll be headed home with a RISC-V laptop. It's absolutely amazing to see this kind of progress in the community. And while many things have been in development stage, we're seeing so much progress and so much investment and so much growth for China in particular.
For sure, yes. I think I noticed the topic of this year's summit is about ecosystem. So in your mind, what does ecosystem mean actually?
Yeah, so ecosystem is a funny word, right? I mean, it comes from biology. So maybe it means, how are we as people coming together around this? But yes, in the business world, ecosystem is the collection of stakeholders that make this possible. So we have stakeholders in our community ranging from engineering students to large multinationals and everything in between, from startups and venture capitalists, tools, software, IP, you name it. There are so many interests at stake here. For us in ecosystem in particular, we see that advances for the embedded and sort of lighter weight processors have been moving quickly for some time, and now we're starting to see similar traction at the high end of computing, so around enterprise, HPC, and other types of workloads.
Right. So why did you think like ecosystem is so important? Why can't we just develop the chip by ourselves and just play with it? Why should we build up an ecosystem?
Throughout history, when we have challenges, we have opportunities, the best and most durable long-term way to overcome or seize those opportunities is when we come together and collaborate, right? And so collaboration is absolutely what this community is about. And ecosystem is really kind of another word for community. We in communities need each other. Software needs hardware, needs tools, needs verification, needs students, needs multinationals, needs customers, development partners, and supply chain. We have vested interests collectively, so when we collaborate and work together, it's even that much more important.
Oh yes, so I think many people is actually curious about RISC-V, because RISC-V is talking about many places, but not many people actually know what RISC-V is actually.
Yeah.
So in your opinion, what's RISC-V?
So RISC-V is a global standard. It's not software, it's not open source software, it's a global standard. And Global standards in hardware actually started more than 100 years ago in the UK, right? Those are the first global standards that we started developing. Now, we never did decide to drive on the right-hand or the left-hand side of a car, but those are, some of these things are examples of standards in hardware, right? So, your plug adapters. And now, come to the modern age and we think about things like Ethernet. So Ethernet is an example of a global standard. Prior to that, there were lots of proprietary solutions that you had to, go with a particular way of networking in your data center. And now with Ethernet, you can plug and play anything because you know what that frozen, ratified global standard looks like. So turn to RISC-V. RISC-V is a open global standard instruction set architecture. So that means here's your base blueprint for designing cores and then building into SoCs and other implementations.
But for normal, for the conventional computer chips, if you like, we got x86, we got ARM, right? But it's actually x86 got a trend for self-PC, personal computers. And ARM catch the trend for mobile computing.
Yeah.
But what RISC-V catch, or how does RISC-V going to lead or the trend for technology development?
So funny thing is, RISC-V is not brand new, right? I mean, if you look at the last several decades of computing, there have been more than 50 different architectures. But the world converged on x86 for servers and laptops and kind of the higher end. And the world converged on ARM for mobile and embedded and other types of devices. And those two architectures really, kind of had just about all of the market. I mean, 99-something% of the market up until 2020 was dominated by those two. Now, those are both proprietary models. You had limited ways to customize. You didn't have as much transparency to really come forward with innovation, differentiation, and new design ways of thinking. So ARM is a RISC-based architecture that was born in the 80s, along with the original RISC architectures in a Berkeley lab, right? So RISC-V is the fifth version of that is now frozen for the test of time. And there's not going to be a RISC-6, 7, whatever. This is it. Because again, when you set a global standard, you set it for the test of time, for generations of computing to go forward with. So RISC-V was born in that time, but it is the most prolific, open global standard that we've ever had. And that's important because that means anyone, anywhere has full transparency to all of the instructions included, as well as various extensions you can plug and play on that. And it's built a bit different than the other architectures. So the other models have been incrementally built over time, so they're massive. And RISC-V said, you know what, we're taking a modular approach. So here's a small base with a menu of other things you can add on to that serve your specific design. And that modular approach makes it much more flexible and easier to work with for engineers.
Okay, I'm happy, like you mentioned, quite a bit of interesting point. One is the many people is actually have access, or everyone actually have access to the instructions and stuff. But many people is actually raising concerns about the fragmentation thing about this one. When people talking about RISC-V, they'll say like many people actually work on the same thing. Like I make the chip, the other one make another RISC-V chip. And so those two may not be that compatible, although they run the same instruction set. So what do you think about the RISC-V fragmentation? Would that be an issue at all?
There are natural forces working against fragmentation. So the world doesn't need to relearn whether to put the steering wheel on the right-hand side or the left-hand side of the car. The world says, you know what, we should have all decided on one way of doing things. And so by having a global community like RISC-V, we are determining not just the base, but the extensions, and together collectively saying, let's do it this way. And then let's compose some of those most frequent models into profiles. And then let's use profiles to build into platforms for specific industries and implementations so that you don't really want to go decide to put your steering wheel somewhere else. You want to ascribe to that standard recipe so that you remain compatible across the field. You want all software to run on your implementation as well as any other, and perhaps optimize to it, but you don't want to go have to build your own software ecosystem all by yourself.
Otherwise, you'll be ruled out of the game, right?
You're on an island by yourself,
Right.
right? I mean, you decide to create a new plug for your electric outlet, guess what? You're on your own. Good luck with that.
Yes.
You're going to have adapters to go with that, right? And so, the natural forces that work against fragmentation say that, I as a company don't want to go do something wildly different than everybody else. I want to add my differentiation and competitive value, but the base needs to glue in with everyone else. Otherwise, I'm going to need to go build my own ecosystem of software, tools, everything else. And no single country or company can afford to do that.
Exactly.
Right? And so when you build something, you want to have access to global development partners, global supply chain, global market opportunities. You cut yourself off if you go off and do something wildly different than what the base recipes are.
Okay, but that's a good point. Like if you got a group of communities to decide, what's the future trend of that. But how do they decide, on what basis, like saying like we should go that way instead of go that way, like we should put our steering wheels on the right rather than on the left?
Yeah.
How do they decide that?
So we have a lot of governance in the RISC-V international community that helps to, we are the stewards of what those extensions look like, what those ratifications look like. So as the stewards, our role is to bring these interests together and say, all right, let's make some decisions on what we want to freeze as the global standard. So we have, 75 different technical work groups that are working on the different menu of items that you would want to use in composing your design. And so, it's really exciting. Sometimes there's lots of debate and sometimes there isn't a lot of debate.
Yes,
but everything that gets ratified goes through a whole process of review, debate, dialogue, public review, and then ratification and votes through our governance mechanisms.
But would the decision process going to be published open source as well?
Yes, so everything we do as an organization is transparent. So anyone, anywhere can see where the progress is on these different work groups and all the way through to finalization. Now, to engage in the dialogue, you do need to be a member. And membership is, pretty reasonable to RISC-V International. And we have a lot of folks that come on board and participate actively in those discussions.
I see. Like I said, from x86 or ARM, like they made their decisions.
Yeah.
And for the end user, you have to use it or accept it or not. But for RISC-V, the openness, like everything, the decision process is open, the results is open, everything is open, so you can have a clear view of the progress of that. I think that's the beauty of open source, isn't it? But actually, many people actually compare hardware to open source software, because open source software is actually leading the technology trend, like all the internet companies, big tech firms, internet, machine learning, AI kind of things. What do you think is the similarities and differences between open source software and hardware, i.e. RISC-V?
Yeah. So there are a lot of similarities. In both types of communities, we openly and transparently collaborate for the best decisions to bring us forward. Also, in open communities, you have a lot more eyes on the quality, right? To spot bugs or understand where we may be taking a turn that will have a different consequence in the future, that you want to make all decisions in the best interest of the long-term future. So I think open source software is in 99% of software today, right? And it really kind of gave credibility to the notion of collaborating for best outcome. Now, in both scenarios, global standards as well as software, open source software, they enable you to accelerate your business interest. So by your teams working shoulder to shoulder with experts in your domain, you are able to kind of progress your learning, your technical roadmap faster. You can reduce development needs by using open building blocks, right, rather than creating your own.
Right.
And of course, that whole ecosystem that you don't want to support alone is then supported by that community.
Yeah.
So there are a lot of similarities. Open source software tends to evolve over time, where global standards are frozen. So there are some nuances like that are just base differences in what you see in hardware and software.
But many people are actually concerning the ownership of open source, both in software and hardware. For example, like if you got open source software, and you got some licenses, but it's saying like if you're using that open source software, the stuff you be building on have to be open sourced based on the license, some of them. And some people are actually worrying like if I take some random open source software, does it secure? Does it actually meet our safety requirements? I think in hardware it's more critical in terms of the ownership, because in terms of designing a chip and put it on phones and like laptops and electric devices, the ownership might be more important. What do you think of that?
So everything we do in RISC-V is issued under global open source license, right? And so those parameters say that, first of all, we don't accept licenses where you then need your implementation to be open source as well, or open as a global standard. We don't require that in any of our licensing. But once you put something into, open global license, any implementer is free to, take that, modify it, keep it the same, what have you, and compose their own design. So there is, some, reliance on the implementer on how they want to leverage that code, right? When it comes to security, security starts with transparency.
Right.
And if you're able to fully examine everything that goes, all the ingredients that go into your solution, you have a much stronger chance at mitigating and managing for the security that you need to do. We have many implementations and designs in course that have gone through ISO specification type credibility for safety and security. It's very important in fields like automotive.
Yeah.
Companies like NXP are specifically using RISC-V for their security module. So these are things that, with the same level of diligence and discipline that you put into any other design, that you bring to RISC-V, and have the additional option of that full transparency.
Okay, I'm happy you mentioned about the applications of RISC-V, like in automobile, actually a lot of companies is actually using RISC-V. But again, conventionally, people thinking like RISC-V is mainly for low-end products, like MCUs are very small chips for electronic devices. What would you think like RISC-V, the role of RISC-V in high-end chips like CPU, high-end CPUs and data centers, high-performance computing?
RISC-V is got its start in the lower power, lighter weight type implementations because those often are not reliant on the same kind of ecosystem to gain traction in the market. They can singularly support the workloads that they do. We are now seeing many examples of RISC-V moving across the full compute spectrum into enterprise, into cloud, into different implementations. What we've noticed in our community is that there are more startups there's more startups in RISC-V than any other architecture in history.
Right.
Because it's a level playing field. You can start your company on RISC-V and not have to need the same level of investment or funding that you would in taking a proprietary approach that relies on licensing and royalties and other schemes to get started. So that's opened up this opportunity to go after new types of workloads. So, we both hear about AI every day, right?
Exactly.
And everyone's adding AI to everything, or just doing AI in isolation. So, you have these new workload opportunities. So when you make an architecture decision, you think about the technology, the business side of it, what level of flexibility and differentiation can I have if I take this approach? And so we're truly seeing that come across the whole field. Now, We also have examples on the high end. Alibaba and others are really kind of bringing this into their cloud computing. Last month I was sitting on a panel with Meta, and they're talking about bringing AI capabilities into their data center with RISC-V. And so there's a lot of exciting new frontiers that we're seeing now come to fruition.
Okay, that's interesting. But like previously, I was working on the data center type of chips from the x86 company, right? Currently, at least in data centers, like x86 architecture is still dominant, in my opinion. And even ARM is
and by the numbers too.
Yes,
it's not just an opinion.
Yes, and also we see quite a bit of startups trying to using ARM architecture to go into high HPC and data centers. And so actually they're successing, but it's a very small number of companies. So what do you think, like in compared to those type of the x86 and their ecosystem, what's the opportunities of RISC-V?
So, at the end of the day, when you think about making that strategic decision and you look at where RISC-V is, RISC-V is benefiting from the collective investment and the shared strategic value of an entire community. So while we may not have the same ecosystem depth and breadth of the other proprietary architectures, we are rapidly gaining ground. Because when you pull together the collective and that shared interest also reduces the risk in making that decision, because that risk is no longer on one proprietary decision maker. It's your collective and independent future that you get to control.
Right, I can see the momentum going for RISC-V, but like in many technologies, like you need a killer applications or product. For example, like M1 chips, when it's launched, everybody's shocked. Like they didn't expect like an ARM architecture is actually performing much better than x86 in personal computer. What do you think will be the number one factor like can drive a win for RISC-V, especially in data centers? What's missing?
Wow, I don't think it's just one factor, right? I mean, you can control so many of the variables of your design, from power to code size to optimizing for efficiency of whatever that workload is, that there are going to be killer apps across the spectrum. And there already are. We're already looking at strong performance benchmarks, at the high end, mid and low end. We're seeing, adoption at scale when it comes to, kind of plumbing in RISC-V into cell phones, into, Bluetooth or Wi-Fi types of capabilities in cell phones are very prolific. There are companies like NVIDIA who have been using RISC-V for many, many years as part of their microcontrollers, right? And, the beauty of RISC-V is that you can use it alongside other architectures. But we do see an increasing and rapidly increasing trend of replacing other architecture decisions across time and going forward.
I'm going to talk about something like many people are actually also very interested about, which is money and monetization, actually. So when people talk about open source, the first word they're thinking about is contribution or sacrifice, if you know, on another way. So you're basically devoting your time, devoting your effort in developing something, like for example, a software app, and you open source it, people can using it. You feel self-accomplishment for sure, but it's very difficult. Sometimes it's a bit difficult for them to monetize from it. Although, like for software world, people figure out ways to monetize it for putting ads and stuff into it, but we can't put ads in our chips, right? So in terms of hardware open source, and companies would like to be part of this trend, open source trend. What do you think the monetization coming from?
Yeah, so open hardware is about base building blocks, and think of those as the low level stuff. We all need this piece, that piece to compose a solution. And you want to have shared base building blocks and the ability to add your killer app on top of that, right? Your killer implementation. And you're not selling the base building blocks. Those are commodity. It's like you can get the bricks to build your house from anywhere. what you want to specialize in is the finishes, the
Yes.
The fancy stuff,
Interior,
right?
yeah.
The things that make your solution better than anyone else's, right? But you don't care about the cement and the bricks, right?
Right.
So let's all decide to have the same bricks and cement, and then go make the house on top of that is the right size, shape, and features that serve your particular stakeholders. When you think about how that works on the monetization side, open source is not free; it's freedom.
Right.
It's about freedom to innovate, freedom
What's
of
different?
design, right? It's freedom to go and do anything you want to do, and then go to market and be wildly successful with it. So it's the composing of your design with your special features that drive your business decisions, right? And for some, being able to sell, the special features or the, custom IP is the business model. For others, it's the end implementation. It's the end product that you wear on your wrist or you carry in your pocket.
Exactly. So I think that's a very good point. So people caring about a thing, not really because of this short trend, but it's more of this long trend. So for RISC-V, I see from your keynote you mentioned about the innovations of RISC-V, and you specifically mentioned about three pillars of RISC-V innovation. One is domain-specific extensions, the other is platform standardizations, and the building on a contributor culture.
Yeah.
Can you elaborate a bit on the innovation side of RISC-V? How does RISC-V will enable people to innovate?
Yeah, so we have reserved coding space to allow for specific extensions, and that's where you can really fine tune your chip design at the very smallest level. So that allows for folks to come in and really optimize. You can't do that on any other architecture.
So how for other architectures, how do they do that? Like for x86 or ARM, if I want to add in AI capabilities into that, how do they do that?
Well, they charge a lot of money.
For sure.
That's a whole nother variable, right, in your decision making. It's one of the trade-offs, right? There are royalties, licensing, and other schemes that are required for things.
So they will
like
build
that.
the chips for you, or they will build the solutions for you. But so what you have is, instead of a kind of a standardized thing,
right?
You get a product,
right?
But with the capabilities, you have to pay for it.
Yeah.
But for
So think about it as with the other architectures, you get the entire foundation for the house. You can't decide to do a different shape or size.
Right. But for RISC-V, you got flexibilities to decide
exactly.
whatever you want.
Yeah.
But based on the guidance from the foundation, right?
Right.
From the international.
Yeah.
Right. Okay. And anything else like the platforms kind of standardization? You mentioned about that, right?
Yeah, exactly. So we're cultivating a set of profiles that then build into platforms, which are similar to what you would find in other architectures to ascribe compatibility, and that gives assurance to all the stakeholders that your solutions are consistent with the expectations that you would have for that RISC-V solution from anybody else. That helps our ecosystem to fine-tune their software or their other pieces to work specifically with those the extensions that are in that particular composition.
But if you got a group of people who's going to decide what's the future trend of this standards going to be, how would you avoid bias? Like, for example, if I've come from big companies, I've got the power, I've got the resources. How would you avoid them to affect the right way?
Yeah. Well, the beauty of open source is that each of those stakeholders, you just get one vote. Because you're a big company doesn't mean you get 10 votes, and a small company just gets one vote. It's governance, right? And it's a meritocracy, right? It's the democratization of technology, where you all come in with that, citizenship to issue your vote in a way that allows for lively debate from all sizes of stakeholders. So that's a very important kind of guiding principle in the open collaboration communities.
And decisions may not be because of the resources, but because of the right, it's the right way, right things to do.
Yeah,
right?
exactly.
Perfect. Yes, I'm talking about quite a bit of concerns about RISC-V, but there's another concern. So people When transferring from the conventional architecture to RISC-V, they got concerns like, I need to rewrite everything, I need to rebuild our system, I need to rewrite my software, and there seems to be a lot of stuff to do. But so from your perspective, to persuade people to switch to RISC-V, what's the stuff like you need to do to let them to join the new trend?
Right. It's interesting. This has kind of happened before, right? At one point, we basically got all of our instruction sets from Intel. And then along came ARM and mobile phones and iPads and things, and the world learned to move from a CISC architecture of x86 over to a RISC architecture of ARM. So if you've already made that journey, the journey then to RISC-V is not as profound as one might imagine. It's actually, when I go out and talk with the folks in the community, they're like, wow, that was a lot easier than I expected. We did that really fast. And actually it turned out more compelling than we initially thought. So there is that already happening. Now you have to think about the interests of the software community. If if you have your killer app, right, and it runs great on x86 and ARM, and you see this revolution in RISC-V coming along, you want to participate in that. It's in your business interest to ride on all three. Sustainable businesses are almost always have multiple business interests, right? And so that enables both sides of the stakeholder relationship to benefit.
Right, so like a mutual attraction from both sides. Like if you're a developer, you want to make sure your app's being exposed to many people as possible. So which is the hottest platforms architecture, you want yourself to be involved. But on the other side, like the hardware would like to be, to participate in as many areas as possible as well. Like it's kind of a mutual thing.
Yeah, I mean, when you look at the examples out there in the operating system distros, they run on multiple architectures. And they're running on RISC-V, right? And, so this over the last year, you've heard us talk a lot about Android on RISC-V, right? Because that's where the momentum is. And if you're running Android on RISC-V and you're an app developer, you want to participate in that too.
So we also see some of the operating systems in China, like OpenOla and all kinds of stuff, is actually being adapted to RISC-V as well. So it's actually making progress. But I'm happy you mentioned about open source operating system. So many people are actually taking that as an example of the comparison between hardware and software. So for open source software, Linux is the kind of the example. But like I said in our previous discussion, it's kind of the application of open source software. Many people are actually building it, like contributing it. It's like a tree, but it's got many branches and leaves and things. But this is the tree itself. But in RISC-V, is there something going to be similar like Linux in open source software ecosystem?
So the base ISA of RISC-V is the trunk of that tree. And the extensions that we ratify for everyone to use are the branches. And then the leaves and the flowers and the fruit are what the community can bring to their specific implementation.
But the Linux is actually the product. If it's the right word, but this is the actual thing people can directly working on. But for RISC-V, for ISA, this is something like kind of standard. You have to build on your product based on the standard.
But you can compose your standard with extensions any way that works for your implementation. So and by the way, if you want to go do your own, you can do that too. But there's, again, forces working against that.
Absolutely. I see the point. But my question is, so like the Linux in software, is there some sort of product, or would you think like if there's going to be a product, like it's going to lead the development of this, of the open source hardware?
I think we're seeing examples of that across the board, whether it is for specific AI accelerators, or if you're looking at some of the automotive implementation. So there are different kind of groupings of implementations across many of these different industries that are sort of already leading the way, and it's exciting to see new people then coming on board and saying like, okay, I need to like kind of follow some of these models that are already out there. and then look for where my added value is. So when you look at open source software, you often have the community version, and then you have like the enterprise class version, right? And then you have services around that and other aspects. So it does kind of create for an entire, kind of business dimension. Now, if you're contributing to those base community versions of things, for us, those are the ratified standards and specifications. You know that your strategic future is built into the base, right? So then you know that as you've participated in that you have insight to kind of deliver on your differentiation beyond that.
Okay. I think that's interesting. That inspires me of the differences between those. Like software is basically you can using it across many applications.
Yeah.
It's kind of universal solutions or stuff. But for hardware, it got so many applications. We probably can't have a one solution, so one shoes fits all type of solutions.
Right.
So for each type of area or applications, you may have your own leading or like mainstream, if like.
Right. So that's where profiles and platforms come in.
Okay.
Right. So you can take your bag of flour and eggs, and you can make a pastry. You can make a loaf of bread. You can make pasta.
Sure.
But you have the same building blocks.
Exactly.
And you compose them in different ways.
Exactly, and they all following the same protocol and standardized standards.
Exactly.
Yes.
Yeah.
Okay, perfect. So let's talk about China, so first, what do you think of the role of RISC-V International, since you're CEO of that? So what do you think your role and the role of international this like in the whole development of RISC-V?
Yeah. So I'm glad you asked, because I am so proud and impressed with the traction and the investment and the development that we've seen around the world, right? So, I've been with RISC-V about 4.5 years. And through that time, I measure every single month what is the global distribution of interest in our members.
Okay.
Since I've started, we've had about a third North America, a third in Europe, and a third in APAC, with about 15 to 17% total in China.
Right.
So that has remained consistent. So as the world is growing with RISC-V, so is China. And what I see here is deep investment across the board, from students in their engineering careers just getting started, and we help to support that with online training and certification as well, even in Chinese, and then building into some of the startups and the new businesses. And over $1 billion have been invested by VCs into startups in China around this topic. In fact, one of our board members started $1 billion fund just for startups on RISC-V in China. And so, the kinds of investment we're seeing from small companies to large companies, Huawei and Alibaba and Tencent and others are really invested in bringing RISC-V into sort of their strategic future. And it's that collaboration that we're seeing, along with the software community, that are really deeply engaged, and we're seeing the progress of that as China is leading the way with things like bringing Android to RISC-V, as led by Alibaba, as in bringing implementations from wearables to servers and switches to fruition as well.
So what do you think, like, the future trend of China's like future role in the RISC-V development? Would you think like the portion you just mentioned is going to be changed, like in the future?
I don't see that changing. Throughout my career, even before RISC-V, China has been a great open source citizen of the world. When there's a call for contribution to the global standards, they have rolled up their sleeves, hands-on code, and helped us, right? So we have development labs in China. There have been many partnerships and many relationships that have grown with China, and so we see that spirit of contribution very strong in China, supported in all levels. And we also see that spirit of entrepreneurialism, that spirit of building a business for sustainable success is also very strong in China. So we see that continuing, and that's something that we really admire.
Right. Okay. Perfect. And So what's about the difference between and for example Europe? Because I've been to the Europe Summit this year, and I see quite a lot of people as well. But I feel slightly different because my personal view of the Europe is like they got quite a bit of technology development, very detailed stuff. But in China, you can see like it's got lots of products. Like you got lots of chips. Many startups are actually shipping their chips, all kind of stuff. My point is like my feeling is like Europe companies like focus on the technology itself, but China is moving really fast already on. I'm not saying which one is better, but what do you think is the difference between both or like around the world maybe?
Yeah. So I see differences regionally as well. I think that in Europe you have a lot more collaborative research organizations and university things, like Barcelona, ETH Zurich, and other Fraunhofer and others that are collaboration efforts between public and private organizations and companies and universities and government. The European Union has infused a lot of investment into the high end, right, around HPC and supercomputing. And they've put a lot of effort behind companies and organizations to kind of further some local investment but global engagement. In China, you see the investment vehicles much more broadly, so from private VC to government to large international organizations that are self-funding as well. And you're correct, that is kind of pushing a lot more products across the field. At the same time, we also see deep academic interest in China, right? So kind of transitioning a lot of the engineering courses that used to run on another architecture over to RISC-V and really investing in talent development as well.
Would you think a talent investment is going to be the key, like in the future?
Oh, talent is around the world, an important topic. And so we see a lot of university engagement in RISC-V. Hundreds of universities are in RISC-V International, and they focus on kind of collaboration around shared resources. So things like labs, lectures, syllabus, textbooks, and we try and like help foster and grow the academic community. We do that through hackathons and student engagement as well. So we're working hard to kind of help bring RISC-V front and center in talent development, as well as through online learning. We've launched a lot of different classes online and have had more than 22,000 people take our courses online. And so we're continuing to cultivate talent, whether it's in the university or folks who are already working in industry.
So would you, I think the answer is yes, but I would like to hear from you. Would you recommend people to like students to learn RISC-V in their schools?
Well, of course, absolutely, right? When I occasionally go look to see, what is the job market for RISC-V looking like? Hundreds of openings every time I look. And that, I think I'm only seeing like what's in North America most of the time. So you have tremendous opportunity. Many organizations are actively training and recruiting for talent. As companies get funding, they need talent immediately, right? I know the Beijing Institute of Open Source Chip, they have a training program, and many of their students have jobs before they've even finished the program. So it's like, no, wait, finish the program, but they're in high demand. This type of talent is in incredible demand, and I think that paints a picture for a long-term great career that is exciting. And if you're excited about kind of changing the future of computing, wow, RISC-V is for you.
Exactly. So would you think open source is going to be the advantage of in terms of learning? Things like if it's open source, we have limited resources and stuff, but if it's open source, would that be easier for students to learn?
I think it's more engaging, because not only are you learning in your studies or in your company, but you have opportunity to engage immediately with your industry to get started on that journey. At this summit, I met students in high school who were already doing RISC-V. I mean, and imagine you're in high school and you can already be part of this, high energy community and make progress. Maybe you don't want to do it in high school, you just want to be a kid. That's okay too. Yeah. But there's huge opportunity here. And everyone that, there are studies that talk about the power of being part of an open community, and that bringing that passion that you have for your work together with a community of folks who also have that passion brings you energy. It accelerates your own learning when you get to work together with folks who are, as invested in that as you are, not just in your own company.
Okay, I think so I'm happy we talk about students learning and career and other things. Many of my audience is very interested to improve themselves, and in technology side it's very important to learn the actual technical skills. But on the other side, for personal development or the soft skills, if you like, I think it's equally important. So from your point of view, what do you think is the most important soft skills you would recommend people to develop?
Yeah. I think regardless of your career path, understanding how to truly collaborate with others is the most important skill you can bring. To truly collaborate with someone does not mean bringing your solution and sitting back and waiting for everyone to get on board. It's, bring your solution and ask for other solutions. How can we look at this together? Be flexible. Think about there are many ways to do something, and how do we collaborate to make us feel like we're both winning here? The long-term goal is we're both successful. Not me, not you, but both of us. And that's hard. That can be very hard for competitors to come together in an open community and decide to both agree on a solution, and it may not be either of theirs to start, but the resulting solution is better. So collaboration is always about making sure that you plus me is better than you plus me, right? It's 1 + 1 is 3, not 2.
Yes, that's a very good point, actually. So collaboration involves a lot of stuff, like you mentioned, like leadership, ownership, communications, and all that.
And be humble.
And be humble.
Be open. Be willing to engage and deeply appreciate why is that perspective different than mine.
It's the human nature, in terms of collaboration. Because I've talked to quite a bit of people. Many people actually talking about ask the same question. What do you think is the most important? Many people actually reason about collaboration. And one fellow is a very senior person is also mentioning this is a kind of a human nature. So we evolved as a human as we are today because of collaboration, not because of self-isolations and fight by themselves, right? So yes, it's a very key point. But and also you mentioned about they got high school students coming to learn RISC-V. I kind of personally am very envy of them in a good way because they got opportunities to study, get access to this lots of materials in their early age. But what about yourself? What would you think you should improve yourself? Or what would you say to 20 years old Calista?
I think it took me a little bit of time, but I very quickly realized that I bring my best self, my best work to my career when I am deeply passionate about what I do. And so you may not know that originally. What am I passionate about? I mean, I ask my own daughters, what do you want to be when you grow up? They're like, we have no idea, But when you find something you're passionate about, make it part of your career. It is possible, right? There are many pieces of every pie, right? And when you can bring your career to a company that works on things you believe in, it may not be the first job that you like, but you feel proud of what that company is doing.
Right.
And the other piece of bringing your best self and that passion to work is to make sure you're surrounded by others that are doing that too. Because that's what makes work fun. That's what makes it rewarding. We all spend quite a bit of our time and effort and energy poured into our careers. So make your passion match your paycheck.
All right. Okay. I think that's the interesting point because previously I had a chat with Yungang about this actually. Talk about this is basically a chicken egg problem. How exactly like your daughter? Because at an early age, a young age, like myself, I have no idea where's my passion.
Yeah.
But for Yungang, he mentioned like you should find something, do something first, and feel passionate about it. But for my personal, I was more on the other side. I find my passionate, like the video kind of thing, and I work for it. What do you think? Like which one is your? I think yours the passion first, right?
Yeah, I think that you are inspired by the people around you.
Right.
So when you have, as you go through school, you have many different teachers, and you can tell which ones are deeply passionate about what they do, and some who are maybe just kind of delivering information, but their heart isn't there.
Right.
And sometimes it's those teachers that help you to realize your passion for something or that you're not passionate about something. So I agree, you need to try things on to either learn what works for you or what definitely doesn't work for you.
Okay. So what do you think is the most valuable skills or like qualities in terms of the professional, regardless of their majors or like in the area?
Yeah. When you think about what part of a company or what industry or what exciting thing to spend your career on, look at what's moving forward. Don't look at something that has been the same for tens of years, decades, and generations. Look at what's moving and changing, and the hot topics, because that's where you're going to find a lot of that passion and energy. Today I think you might say that it's in AI. There's a lot of passion and energy and excitement there. And by the way, that's probably one of the big game changers in our world. Well, RISC-V is one of those game changers too. So when you hook your career onto a star, make it a shooting star, not just something that's kind of just there been blinking for many years.
Beautiful. Okay, beautiful. So so in terms of personal development and continuous growing, you got any book or any materials like from your life or career like you would like to recommend to the people?
Yeah. It's kind of interesting. It's a great question. I don't have a book or a podcast or anything that I say. I say the opposite. Turn everything off. Go exercise, go stare at the clouds, go take a piece of a meaningful time to step away. Because that's when the ideas hit you. That's when you feel the most like strong emotions about something, to allow yourself to process things rather than completely just blinders on, grinding away every day and looking at your phones and thinking about all the information flying at you. Turn everything off. Take that moment, and it may be a small moment every morning when you're having your coffee or tea. It may be a weekend where you can take a day and just step away. For me, I exercise an hour every day, and I turn everything off.
Awesome. Okay, awesome. Thank you very much. That's all my questions, and thanks for your time for today.
This has been a fun discussion. Thank you so much.
Thank you.